So in the last class, we have seen how to create a thread, by extending what is called as thread class. Okay. So whatever the thing we have written here, that means from a class my thread extends thread, right? So complete this particular class is nothing but thread definition, we said, right? Thread definition, this is the definition which you have given for a particular thread, right? Now, and what is the name given for that particular thread? The name given is a my thread. Okay. So when you are calling this particular thread, when you are putting this particular thread into an execution, you said that a method which is called as a run will be under execution, right? And whatever things you have written with respect to run method, okay, whatever things you have written with respect to run method, these things are considered as job of the thread. Job of the thread in the sense, if you are calling this particular thread, this particular set of instructions will be under execution, right? So that is job of the thread. Okay. So how you started this particular, so means what is the procedure to start a particular thread? First you need to create object of this particular thread, right? So what is the class name? My thread. So using a my thread t is equal to new my thread, you will be creating object of this particular thread. Okay. So once you are able to create a object of that particular thread class, you can call the method called a t dot start. Now we said that when you are using a t dot start, internally it will be calling a method called as a run method. So you are in a position to execute this particular job of the thread. Okay. And we clearly said that if you have a requirement wherein which you want the execution should be done concurrently, that means independent tasks need to be completed, so there should not be any dependency with respect to the task, right? In only those scenarios you'll be going with what is called as threads, right? And here in this example you have written throws exception for the main method, just because you were using a thread dot sleep. So when you are using a thread dot sleep, it will throw an exception called as IO exception. So you are handling that particular IO exception over here. This is the revision of whatever the things we have discussed in the last class. Okay, and we clearly said that here instead of writing a t dot start, we can write a t dot run also. If you are writing a t dot run, this will be just a normal method call or a function call, and you will not be implementing any concept of a thread implementation, right? So if you are writing a t dot run here, then your program will be just a sequential execution of the methods, right? We will do a small postmortem of this particular program. Okay, if you are clear, then answer this particular simple question. What is a thread scheduler? What is its work? Only one response. It decides which thread have to run. Okay, only one thread can run at a time. Okay. Any other answers? Then I'll answer your question. What is the difference between start and a run method? Okay. Right. So thread scheduler will come into existence, or thread scheduler will get a task when you have more than one thread need to be executed. That means when you are running a main method, when you are starting your program, generally main method will be loaded, and we said that once a main method loads, there will be a something called as a main thread, right? And we clearly said in a starting class that main method is different and the main thread is different completely. Okay. So when main method is under execution, so when it is only one thread, so no need of this particular thread scheduler, right? Scheduler in the sense it is going to assign, it is going to schedule which thread need to take a priority, or which thread should be under existence, or which thread should be under execution. This is nothing but a thread scheduler, right? When you have a more than one thread which is ready for the execution, right? In that scenario, thread scheduler will decide whichever thread has to be given the priority for the execution. Right? So thread scheduler will decide will decide which thread should be given access or priority to execute. Right? So this is the work of a thread scheduler. Right? So when a thread scheduler decides that, say for example, thread 1 need to be executed, okay, when thread will be ready when you are writing t dot start, that means you are starting a thread. Right? When you are starting a thread, internally there will be a three things which are going to happen. When you are starting a thread, internally there will be a three things which are going to happen. What is the first thing? The first thing is registering thread registering a thread to thread scheduler. This is the first thing, saying that this particular thread is ready, and you can so means you can assign so means you can allow this particular thread to execute its job. This is the first task which the start method will do. Second task performs some, or I can say registers for some mandatory resources. That means whatever a thread is expecting, or what are the things that are required for a thread to perform its task, all those things will be assigned to that particular thread. That means once a thread is under execution, there should be a parent thread for that. There should be a some properties, that means some space available for that particular thread to execute and all, right? So all those mandatory resources will be allotted in the second step of a start method. Then after doing this, it will invoke run method. It will invoke the run method, right? So whenever you are writing a thread dot start, right, so these three things will be happening internally. I hope I answered a Dan's question. Okay, now, so because of this reason only, we have said in the last class, in an example, we said that if you are writing a t dot run, we said that this will be a just the call for the run method, not starting the job of the thread. Right? So these things which we have discussed in the last class. Okay, so coming to the points which we need to discuss in today's session is, one second, I'll be doing a small modifications and you need to answer whether those modifications are valid or not. Okay, I'll not write anything over here, so I just wanted to keep the things simple. One second, let me remove few statements, means no need to go with a for loop and all, just a normal execution. Okay, so starting a thread, I'll not make this thread to a sleep. Okay, right, so I'll just make this particular main method here. Right, simple program. Okay, so here let me write system dot out dot println, right, from thread. Right, so now who will be executing this particular statement? Your my thread, right? So whatever t dot start you called, so this particular t dot start will create a thread for you, registers that thread to a thread scheduler, assigns whatever the resources need to be allocated for that particular thread, then invokes a run method, right? So this particular t dot start will do all these things, right? So as a part of a implementation in a start method, it will be calling this particular public void run method, right? So now at this particular point you will be having a only main thread. So after writing a t dot start, you will be having a two threads. One is a main thread and another one is thread called a t, right? So thread scheduler can allow any of these particular threads to perform their action or the execution, right? So you may get output something like a from thread, main thread, right? If you are repeating your execution, some point of time you might be getting a main thread will be executing first, then your child thread might be executed later, right? Simple program itself, not done any complications. Let me just run this one, later I will modify. Main thread from thread, main thread from thread, and from main thread from thread, main thread from thread. So it completely depends on a job scheduler how it is going to give a priority for existing threads, right? So even though you are calling a t dot start here, so in output you can observe that first a main thread is under execution, this system dot out dot println, then you have a from thread, right? So it is up to the job scheduler which thread should be under execution. Clear? Now let me add a question. So this is a question, this is the topic with respect to our today's session which we have not discussed in the last class. Can I write a statement something like this? Is it valid? Can we write a statement something like this? What we have done, what this concept is called as method overloading. Okay, so now the question is whether with respect to run method, with respect to run method, run is also normal method itself, right? Question is with respect to run method, can we perform method overloading? Is it valid? Or will a compiler says, you idiot, why you are writing a method overloading with respect to run? Will it show any errors? What might be the answer if I am executing a program something like this? Okay, let me simplify a question. Will it execute or will it show error? That is the first question. Will it execute or will it show errors? Saying that you cannot write a run with arguments. Will there be something like that? It will execute. Okay. It will run, I think. Okay. So let us just cross check whether the thinking is correct or not. Compile time it is showing some interrupted, no problem. Apart from that, it is not showing any error, right? So no problem. That means you are allowed to have a overloading with respect to run method, right? Okay, so you are saying that it is allowed to have a overloaded method with respect to run. There is the point wherein which it will be executing a system.out.println of argument. Are we getting that particular output? Are we getting the argument as output somewhere? Executed fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, nowhere. What is the conclusion need to be drawn from this? The conclusion to be drawn is it will allow you to have the method overloading with respect to run method, right? But whenever you are calling a t dot start, right? Internal implementation of a start method has been written in such a fashion that every time this particular start method will call zero argument run method only, right? So every time this particular start method will call this particular run method only. It will not call any augmented run method, right? It will allow method overloading, but your start method will be calling a default run method itself. Clear with the things? Shall we do one more modification? Yes. My one more modification and output I am expecting from you. Question in the chat box. Sir, what will happen if we pass an argument to t dot start followed by int? It will say that that particular means that is not the way how you need to call that particular start. You can check that one later. Okay. Right. So now the next question is something like this. This itself is a question. Can we have a something like this? Can we write a program something like this? What are the things we have done? We have created a class which is called as a mythread, which is extending the threads class. Okay, let it extend. Now, this particular mythread is nothing but a type of a class which is of a thread itself. That means they are similar now. Okay, similar. Now, creating object of this particular mythread t dot start. When we what we have said, when you are writing a t dot start, it will be doing the three things. First, registering that your thread to a scheduler. Second thing is giving the resources for that, and the third one is to call the run method. Right? Have you given a run method implementation? Have you given the run method implementation of run method? Not given. Okay, if a implementation of a run method is not given, then what that particular JVM will do? Let us just cross check. Not showing any error, right? Not showing any error. Let us just run the program. What it will show? What it is showing? It is just showing a main thread, right? This is a command java thread demo, right? It is showing output only with respect to a main thread. That means you don't have any implementation written over here, right? Is it working according to our requirement? Is there any problem over there? What is my question is, say for example, you said that when you are writing a t dot start, you said that three things will be working, and the last statement is invoke a run method, right? So when you are saying a invoke run method and you don't have a run method defined here, so what about that particular third statement, invoke a run method? Won't it show any error saying that you are saying to invoke a run method and I am not able to find any run method over here? Won't it show such kind of error? If it is not showing error, means obviously it is getting that particular run method from a somewhere. This particular start method will invoke a run method. Yes, you are saying correct, but you don't have a given a definition for a run method over here. But where is the exact definition? So means, are there any other place where you have a written a run method definition? Yes, I have written. It is there in a thread class, right? When I am writing a public void run, I was overriding a run method in a thread class. When I was writing public void run, I was overriding the method which was defined in a thread class. Right? Now, if I don't give any definition over here, what does this particular t dot start will do is it will call its parent class run method. Right? Is there any implementation with respect to that? Nothing is there. That is the only reason why it is not showing any output over here. Right? So your thread class will be having method definition for a run, and there will not be anything defined with respect to run method in your extended class. In your extended class, if you want to give any definition, you can give here. Right? If you have given a definition here, this particular start method will be giving you whatever the implementation that has been given in overrided run method. Hope things are clear, and whatever statements I am making, those statements are giving you some sense. Clear with the change? Shall we proceed with a further change? Next change, public void start. Wow, directly wrote a start method only. Let us see. System dot out dot println from start method. Public void run intention is not to confuse you, rather to give you a better clarification on those methods called start and run. From run method. What will be the output now? Now I am expecting a better answers, means more answers in a chat box. What will be output of this particular program if I execute in this fashion? Main thread from run method. Okay. Any other answers? If you are telling the right answers, you are not be crowned. So means you are not be declared as a king. Okay. If you are giving a wrong answers, you will not be cursed or you will not be put behind the bars. Main thread from a run method. Okay. Any other answers? From run method and main method. Okay. Sorry, main method. Rani Kumari, main method from run method. Okay. Any other answers? Quick, quick, quick. Right. So let us see what will be output. Okay. So main method from a run method. Okay. So majority of people are saying that a main method and from run method. Let us just cross check whether JVM is means what are the things you are written. Same output is there or not. Compilation is fine. What is this? Main from run method. Okay. What is the output you got here? What is the output you got over here? Whatever the answers you have given in the chat box, right? In the interviews, if a question is asked something like this, and if you are answering the same the way how you have posted a messages in the chat box, straight away the next question will be who taught you Java? Okay, so don't spoil my name. Okay, so the thing is, see, when you are writing a t dot start, when you are writing a t dot start, is it not a normal method call? This is how we have seen even with respect to run also, right? So when you are writing a t dot start, that will be a just normal method. See, this will be a normal class and this will be a normal method because you have already defined a method over here. If you didn't write this part, if you have not given override a definition, then the start of a thread class will be under execution. Right? What I'm saying is, if you are not giving a definition for this particular start, that means if you have not written this particular statement, right, then the start method of a thread class will execute. When you have given a definition here, that means when you have overridden a previous definition of a parent class, then why it will again go to a parent class definition of a start method? Right? If a question is asked on these things, how many concepts it will cover? See, it will cover your inheritance concept, it will cover your thread concept, it will cover your normal method calling also. Right? Be clear with the concept. What we are saying is, with respect to a thread class, you will be having a start method and a run method. You will be having start method and a run method. I'm talking about a normal implementation of a thread classes, right? In a thread class, you will be having a start method. So inside a start method, it will be invoking your run method, which is taking a 0 arguments. This is the structure. Now, if you are giving any of these definitions explicitly, that means now you have given a overridden method of this particular start, right? When you have overrated already, why it will go to a parent definition when it is getting a definition here itself in a child class? Method override has happened, right? When a method override has happened, whichever recent definition you have given, that will be under execution, right? Is there any point wherein which it will be calling a this particular one? No, because you are not going with the threads concept. You are performing a normal method call, right? So t dot start. T dot start means you are generally saying to start that particular method. That means invoking that particular method. Yes, invoked this particular method. Normal start. Have you given any definition within this particular scope of a start? Are you calling a run method? No, I'm not calling a run method from this particular point. All right. When you are not calling a run method from this particular point, why it will execute this particular run method? Okay, if you want to execute this particular run method explicitly, you write a t dot run explicitly, right? So in this program there will not be any point wherein which you have implemented a threads. It will be just a functions. That means this will be just a class and a methods program. A class which is called as a mythread is having a two normal public void methods, which is a start and a run, and you are invoking those two methods from the main method. Got the clarification? Now what is the scenario? What will be the output? Will there be any errors? If it will show an error, if you feel like it will show an error, you can say that it will show the error. If not, you can just give me what might be the predicted output. Okay, if no errors, what will be output? Just saying no errors doesn't fulfill the purpose. What might be the output? Did I ask something fishy? Output may be from start method, main method. Okay, run method, start method, main thread. Okay, from start and the main thread. Okay, any other answers? Okay, so listen to the explanation carefully. You will understand the concept in a better fashion now. Now, this definition of a class is there, right? Question and answer. So answer. From the JVM thread class. Okay, right. I am writing means I am creating object of my thread class, this particular my thread class, and I am saying t dot start. Okay, so who will be executing this particular t dot start? Who will be executing this part? It will be executed by my main thread. It will be executed by my main thread. Okay. Now, whether this particular t has acquired a property of a thread? No, it has not means acquired a property of a thread, because it is able to find this particular start method locally here itself. Locally here itself. So t dot start normal method call. Normal method call. Okay. So when this particular t matches this particular start method, so obviously execution will come to this particular part. Yes, execution came to this particular point. What is the first statement that you wrote in this particular start method? Super dot start. Okay, so what does the super dot start means? Right? So what does the super dot start means? You are calling your parent start method to execute. Right? Who is a parent start? Who is a parent of this particular method? So means this particular class. For this particular my thread class, the parent is a thread class. That means you are asking the start method of a thread class to execute. Right? Huh. In a parent start method of a thread class, don't you have a run method call? In a parent class start method, don't we have call for the run method? First, this particular method will be reached. This particular method will be reached. From this particular point, you are calling a super dot start. Super dot start in the sense you are calling the start method of a thread class, right? So once this particular statement executes, right? Once this particular statement executes, it will be creating your child thread. Why? Because you are calling your parent thread, parent start method, right? Parent start method means that is a standard start method with respect to thread class. That particular standard method of a thread class contains implicit invoke for the run method. Now can I say that after this particular point, after this particular super dot start, I will be having a two threads. One is a main thread and another one is the child thread, right? So here you have reached using a main thread. This statement has been executed by the main thread, which is going to give birth to a child thread, right? After this particular line, you will be having a two threads under execution. One thread, that is your main thread, will continue execution of this particular method. Your main thread will continue execution of this particular statements, and your child thread, what it is doing, it is calling your parent start method. When it is calling a parent start method, obviously it should execute this particular job, right? So child thread is responsible for executing this statement, and your main thread is responsible for executing this statement. What will be output? Can't be predicted. First it can print a main thread, then it can print a from start method, then it can print a from run method. But you will be seeing all these three system.out.println statements as the output, but you can. Let us just cross check. From start method, from run method, then main method. That means main thread. Anything is possible. Who executed this particular from start method? Your main thread. Who executed this from run method? Your child thread. Who executed this particular main thread? Main method. That means main thread itself. So it is getting a main thread. Any questions with respect to this particular aspect? Intention of modifying in these many different ways is to make you comfortable with the methods and how to call those things and what is the purpose of those methods, not to confuse you. If you are clear with the things, expecting the acknowledgement, then we will see one more small modification. Okay, now let me remove this statement. Is it a valid way to write a program? Any errors with respect to this? You are calling a t dot start. T dot start is not there in a present class, so it will be calling it's a parent class at start method. So in a parent class start method, after a two so I mean set of instructions, in the last you have a something called as a invoking a run method. So it will be invoking this particular run method. It will be executing this particular statement for you, right? Okay, valid. Now my question is something like this. Can we write something like this? What is this? What confusions all these things? Yes. Okay. If it is S, what might be the output? I'm just adding a one line for every modification, just for having a better clarity. Right. If this is a valid, what will be output? From run method, main thread, from run method. Okay. So let us just cross check. Will it be showing the same thing or not? I guess, sir, 15 line will give error. Okay, so he is saying that this particular line will give error. Okay, so let us just cross check which one is correct, whether it will work according to statements given by Tej Kiran, or will it show error. What happened? Huh. Main thread was executed, your run method was executed. So when you have written a t dot start again, right? So that was a problem it is showing. So what a problem it is showing? Say it is saying a Java line number 15. There is a problem. It is throwing you a exception. See, exception in a thread main java.lang. What type of exception? Illegal thread state exception. That means it is saying that there is a problem with respect to the state of the thread. Oh, problem with respect to state of the thread. Okay. So what important observation you have to remember is, once you write a t dot start, are we starting a life cycle of a thread? Life cycle of a thread, if you remember that particular diagram which we have discussed in the starting session, once we say t dot start, right, it was a so means it was moving from a ready state to runnable state, right? The runnable state it has went. When it is in a runnable state, some other state already started, right? Then you have told the thread to start already, so means thread is under execution. You should not again tell that particular thread to restart, right? If I'm writing a t dot start again, then it is nothing but a restarting the thread. Okay, so this is not allowed. That means once a thread has been started, right, you cannot restart that particular thread. Clear? If you are trying to restart, then it will show you a exception saying that illegal thread state exception. Right? So it will just like, once you say t dot start, once you have started a thread, you have just released a bullet from a gun, right? When you have already released a bullet from a gun, either you need to release one more bullet, right, or you should keep quiet, right? In the middle of a, so means in the traveling, so means when a bullet is traveling in the middle of a journey, you cannot tell it to restart once again, right? Once launch it, once a thread has been started, it is finished, right? In the middle, you cannot allow that particular thread to be restarted. Clear with the things? So if you are restarting, then it will throw you a exception. Okay, if you are restarting a thread, it will show you a exception. Clear with the things? Let me display you the points. If you have any questions with respect to any of those points, you can ask. These are the points which we have discussed. We have discussed how exactly the start method will be there. Okay. Then we have seen overloading of a run method is allowed, but always no argument run method will be called. Right? Second, no run method implemented. That means if you don't have any implementation for a run method, if you don't have any implementation in a run method, then also program will execute. It will be executing a run method of your parent class. Right? Second observation. You can override a start method. You can override a start method. If you are overriding, whatever the new definition you have given, that particular definition will be under execution. If you don't have a call for a run method from that particular start, you will not be having a thread concept implemented. That will be just classes and the method kind of a stuff, right? So by using a super dot start, you can call your parent class start method, right? When you are writing a super dot start, you are going to give, so means you are going to initiate one more child thread. So that particular child thread will be calling the run method. So child method, so means child thread will take care of a run method, and your start method, normal start method, right? Not a super dot start, normal start method will be executed by main thread. Okay, and don't call this particular start method twice, because if you are calling it twice, then you are restarting a thread. When you are restarting a thread, it will throw you an exception saying that thread illegal state exception, right? So which is not allowed, right? Restarting the thread. Okay, any questions with respect to any of these points, you can post in a chat box. If you don't have a questions after this particular session, I'll be sharing this particular recording also. Go through the recording, be clear with the starting first class, means before to this particular session, whatever the things we have discussed, that particular topic, and these observations whatever we have discussed. Now in afternoon session, that is from 2 to 3, we will be implementing a threads by implementing runnable interface, because we have two different ways of implementing threads, right? One is by extending a thread class, and another one is by implementing a runnable method, some is runnable interface, right? So till now we have discussed by extending a thread class, by extending a thread class. In afternoon session, we will be discussing how to achieve this particular threading by implementing a runnable interface, right? So later we will discuss what is the advantage. It means in which scenario we need to go with extending a thread class, and then which scenario we need to go with a runnable thread interface. That means runnable interface. You can leave the session. Thanks for your participation and the time. Have a nice day.